Hello and welcome back to lesson 8.3. Today we're going to have an introduction to probability. So in 8.1, we talked about sets and how we count those sets. And then we learned about Venn diagrams at 8.2 and how we can put them together in a picture form. And now in 8.3, we're going to talk about probability. An experiment is how we get started. So an experiment is an activity or occurrence with an observable result. Each repetition of an experiment is called a trial. The possible results of each trial are called outcomes. The set of all possible outcomes for an experiment is called the sample space. We also denote a sample space with a capital and the items in brackets, such as this. So let's look at a few examples. Give the sample space for each random experiment. Flipping a coin. So I will call that C. And my two possible outcomes are head and tail. An experiment consists of studying the number of boys and girls in families with exactly 2 children. So if we wanted to look at their gender, we could say A equals boy, boy, or boy, girl, or we could have a girl, then a boy, or we could have a girl, girl. An experiment may have more than one sample space, as shown in the previous example 1b. So we could look at the gender of the two, or we could just count the number of females. And so if we did that, our outcome sample space would be 0 females, 1 female, and 2 females. An event is a subset of a sample space. In example 1a above, a subset may be B equals H. That should be C equals H for heads. For the sample space S, in example 1b, above, write the following events. Event H, the family has exactly one girl. So we could have H is boy, girl, or girl, boy. Event K is the 2 children of the same sex. So for the same sex could be boy, boy, or girl, girl. The family has 2 males. J. So that would be boy, boy. Event J above has only one outcome, and thus is called a simple event. When there's only one way to satisfy the outcome, it's a simple event. If an event E equals the sample space of the original experiment, then E is called a certain event. If E is empty set, then E is called an improbable event. Let's look at an example for this. And suppose a fair dice is rolled. Find the requested events. Write the sample space in set notation. So if we roll a fair 6-sided die, I did not state that it was 6-sided, but that's usually what we use. There are 6 sides. What about the event that die shows a 3? And notice I'm just naming my events, whatever letter I would like. The event, the number showing is less than 5. That would be 1 through 4. And are either of the events above a simple event? Yes, A, because there is only one outcome. So it's considered a simple event. Example 4 said, a study of college students grouped students into various categories that can be interpreted as events when a student is selected at random. Consider the following event. The student is under 20 years old. The student is male. The student is a business major. E prime means the students who are 20 or older, because we're talking about not in E, which is under 20. So students are 20 or older. Not in F and in G. So not in F would mean they're female because they're not male. So not in F and G. So they're female and the student is a business major. So they must be both. And math is not an F or G. So any female students, let's see, not an F. So that would be a female again. Female or a business major. So B is they have to be in both, and C is they could be in either or. That's the difference between the intersect, which is and, they have to be in both, and the union is or. That's important to keep in mind. So let's do a little reminder that we learned in an earlier lesson about disjoint events. Disjoint or mutually exclusive events are events that have no intersection. So we have a quick example here for your reading pleasure. But let's look down at probability. Let S be a sample space of equally likely outcomes and let E be a subset of S. Then the probability that event E occurs is the number of outcomes that make E out of the total number of possible outcomes in the sample space. So number outcomes to make E true out of the total number outcomes in sample space. Caution, the basic probability principle only applies when the outcomes are equally likely. Okay, so we're assuming that they're all equally likely. So let's look at, suppose a single fair diagonal. These are equally likely events because there are 6 outcomes, 1 through 6, and they each have the same likelihood of landing on 1 through 6, unless you have a special die that you purchased. E is the die shows an even number. So the probability of E is the number that are even out of the number in S. So there's 6 in S, and the numbers that are even, 2, 4, and 6, there's 3 of them. So this probability is 1/2. It can also be written as a decimal, and probability can also be written as a percent, 50%. F is the die shows a number less than 10. So the probability of F is number less than 10 out of the number in the sample space. So again, 6 in the sample space, and all 6 are less than 10. So that's 1 or 100%. And then G is the die shows an 8. So the probability of G is the number and 8 out of the number in the sample space, which is 6, but there are no 8s, so that's 0. So the probability is 0. So we're not going to dive deep into this semester, but I do want you to be exposed to the three types of probability. If you were to take a statistics class, there is classical, and those probabilities are based on equally likely outcomes, like drawing a card from a deck or rolling a die or flipping a coin. Experimental, which is these probabilities are based on outcomes that come from real life experiments. And three is the subject its subjective probability. These probabilities are based on opinion. Sort of like the probability that the Lions will win the Super Bowl. The probability of an event. For any event E, the following holds. The individual probabilities must be greater than or equal to 0 or less than or equal to 1. And if E is a certain event, that probability is 1. And if E is an impossible event, that probability is 0. And then we already looked at empirical probability is similar to the classical probability, whereas F is the number of times the event occurs out of the number of times we run the experiment. So we're going to look at an empirical probability. So we have data here. It's 2,813,503 US deaths in 2017. They are listing according to the cause in the following table. If a randomly selected person died in 2017, use this information to find the following probabilities. So we have a variety of causes: heart disease, cancer, accident, chronic lower respiratory disease, a few that I've not heard of, diabetes, the flu, which is actually very small, even though it's been a big item talked about with COVID in recent years. So A says the probability that the cause of death was heart disease. So the probability of heart disease would be the number that had died of heart disease out of the number in the sample space. And so the number in our sample space is the 2,813,503. And the number that died of heart disease was 647,457. And that turns into a decimal of 0.2301, or approximately 23%. The probability that the cause of death was cancer or heart disease. So it could be either or. So the probability of heart or cancer would be, we're going to include both of them. So the heart of 647,457 plus the cancer of 599,108 out of that total of 2,813,503. And that comes out to be 0.4431, or approximately 44.31%. And then and probably that the cause of death was not an accident and was not diabetes mellitus. So the probability of accident crime, so not an accident, nor diabetes crime, means that we can take our total of 2,813,503 and subtract away those two groups that we don't want, the 169,936 and the 83,564, and divide by the total in our sample space again. So that difference comes out to be 2,560,003 people that did not die of accident nor diabetes out of the 2,813,503. and that comes out to be 0.9099, or approximately 90.99%. So there's a lot in this lesson with probability, learning how to write them as fractions and decimals and percentages and how to write them. And remember, a probability is the number of occurrences of a number in your sample space. And catch me back for another lesson.